Let me tell you about the conversation I guarantee you have had with client as a developer, or you will have. You build a subscription system, deployed it on the production, user are paying it, and everything works fine. Client is happy, you are happy, until one day a client calls you and says, "Hey, can you just add a premium access to my friend's account? He wants to try it out for the requirement, and he is a really nice guy, so I don't want to ask him to pay it." And you said, "Yeah, why not?" And after the call, you are thinking like that was not the part of the original requirement, and the platform is also not built to support that. Because you know what that request actually means. You need to make some required flag changes into the database for that particular user, and also need to make some required changes into the endpoints to support that particular user conditions. In this video, I will show you exactly how you should build a subscription system architecture for any software or any platform that you are building to avoid such situation in future. So let's start the video. Hi, I'm Kaushik Tank. I'm starting this channel to share the thinking behind building any software that I have learned over the years. See, the code is just a tool to build a software, but you are solving a business problem that required a real thinking. I have seen many videos about various topics, but most of them covers only how to or very basic tutorials about any topic or subject. But on this channel, I will be sharing the real content that is required to build a production ready applications. So if you are interested in learning such thing, do subscribe to the channel. So let's get started now. A quick side note before getting started. This is a concept and it can be implemented with any programming language and any framework and with any payment provider. When implementing the subscription system, most developers just add the detail about the active subscription field in the user table itself directly, and when user purchase the subscription, they just update the flag in the main user table. And this will work as per the requirement until client wants to set some custom access for some particular user. And the story I have said is the architecture problem and not the billing problem. And if you have not come across such situations before, you will not able to imagine such scenarios while designing the system. And because of that, your architecture or code base is not ready to handle it. See, flag will work really well when you are developing and testing the system locally, and it also works till the MVP level. But the moment you start getting the real users, this will completely destroy your production. Now let me show you the next slide. Here you need to increase the API limit for the single user only and not for all the users in a same premium plan. So you cannot manage that with a single flag in the users table, right? Here is the another situation. You have developed a really cool feature and client wants to give the access of this feature to a list of premium users only and not all the premium users and get their feedback. But with the current single flag system, you cannot do that because there is no user level management here. One thing you should be aware of is that billing and permission and access are not the same thing, and you need to treat both differently. The payment gateway will handle the billing and you need to build a separate layer that can handle the permission access separately with the user level access control. And you need to implement this from day one while planning the architecture and building the platform, because the client will build MVP first, that is for sure, but the client will never tell you, now we are done with MVP, let's rebuild it for the production and make it production ready. Because when you deploy the MVP, a user will start coming and you cannot ignore them, and if we are planning to make such changes later on if needed, you need to handle the real users as well. And making such architecture changes after the production release is much more complicated than implementing it from the day one. This is how you should design the schema and architecture. First, you need to manage two separate tables for the permissions. One will be a default permission table and another will be a override permission table. The default permission table contains all the default permissions and access that a user can get after purchasing a particular subscription. or a plan. And this will be common for all the users and no user level access and management in this table. The second table will contain all the user level permissions and override details, and this will manage the permissions at the user level. Okay, so that is for the schema part. Now when a user purchases a subscription, you don't need to make a copy of all the default permissions to an override table. You only need to update the purchase history, current plan and other required tables, and if there is a no custom permission set, then zero overrides in the custom or override table while purchasing the subscription. Why I am keeping these default permissions in a single table? Today, suppose you are providing 1,000 requests per day in a premium plan for an API access. Tomorrow, business wants to change that to a 2,000 requests per day for all the premium users. Now imagine you have duplicated the default permissions, then you need to update all the records that are duplicated. Instead, with the default permission table, you can just update the single record in the default permission table. And this is the endpoint logic. When a request comes, you first need to check the override permission table. If the record found, provide the access, else fall back to the default permission table and provide or restrict the access based on the permissions that a user have. You can also use the override table to restrict the access as well, that is provided in the default permission table. So now, suppose you need to release a particular feature for a list of users only, you can override that by using the override table. So that is also manageable here. I know implementation is a bit complex compared to a simple flag system, but this is worth developing to avoid such situations in future. So that's it from today from my side. If you have found this video helpful, like the video and subscribe to the channel. I will publishing more videos on a system design and backend architecture. If you want to know how to implement this at the code level, please do let me know in the comment, and I will see you in the next video. Thank you.